Here's a quick introduction on the software that is called QM for Windows that you may use to solve linear programming problems, among other things. So let's start. First, let us solve this maximization problem with 4 constraints and 3 variables. So you open the software, and then first you need to do is to choose the module. Here we are going to do linear programming, so choose linear programming. And then after that, in the tab here, you choose File and New, and then this window will pop up. Put the title to the problem is optional, I think. And then the number of constraints, we have 4 constraints in that problem, 3 variables, and then our objective is maximization. Now, once you've done that, and then this window will pop up where you may put the input of the problem. So here you just write down the coefficients, 60, 30, 20 for the objective function, and for all the constraints, and then for the sign of the constraints, these are the drop-down menu. You may just click on the arrow and then choose the sign that you would like to put there for that constraint. Once you have done inputting all the parameters, then you go to the File tab here and then choose File and Solve. There are several windows for the result of this QM software. Usually this is the first window that will pop up. So it shows the result. It says that our x1 equals 2 in the optimal condition, x2 equals 0, x3 equals 8, the z value is 280. And then the corresponding dual solution is because we have 4 constraints in the primal, we have 4 variables in the dual. So y1 equals 0, y2 equals 10, y3 equals 10, y4 equals 10. So those are the dual solutions. And then in another window, you may see like a summary of which variable, whether it is a basic or non-basic variable, and what is the optimal value. Another window titled Ranging shows the sensitivity analysis. For example, for variable x1, the optimal value is 2, and then the original objective function coefficient is 60. And here's the sensitivity analysis. The price of x1 may go down as low as 56, may go up to 80. If these conditions are fulfilled, it means the current basis remains optimal. Otherwise, if the cost of x1 is less than 56 or greater than 80, it means that the current basis is no longer optimal. Similarly, for the constraint, we can see that it has the dual value, which you may say is the shadow price. And then it also shows the slack or surplus, if there is any. So you can say the constraint 1, we only consume 24 because we have slack 24. So 24 plus 24 equals 48. And the original value for the right-hand side is 48. It may go down to 24. It may go up to infinity such that the current basis remains optimal. So this part is the sensitivity analysis part. Now, one of the columns in the previous slide is called reduced cost. For example, x2 has the reduced cost of 5. If you recall, this is the example of Dakota problem, and x2 in Dakota is stable. When we talk about the duality and shadow price, we have seen that the value of the resource that is used to produce a table equals 35. So current cost equals 35. However, the selling price is only 30. That's why we do not produce table. See, x2 equals 0. And reduced cost equals 5 means that either the selling price goes up to 35 or the cost goes somehow you make the cost goes down to 30, then table will be produced. So reduce cost, you can say that the amount that the selling price should be increased $5, or the current cost should be reduced such that table is profitable. And then for those variables that are basic variable, the reduced cost is 0. Now try by yourself to do to solve this minimization problem, and this is the optimal solution for this problem. The difference is that now try to do this minimization problem. And then try also this example, which the conclusion should be that this problem is an unbounded problem. And finally, try this linear programming, which the conclusion should be that this problem is infeasible. So that's the end of all the topics that I would like to talk about in this course. And thank you for being with me all through this semester. We have been through a lot in this class. So we start by learning formulating linear programming problem, solving the problem using simplex algorithm, also big M and two-phase. And then after the midterm exam, we learn about the formulas to construct a table. We learn about sensitivity analysis, the 6 changes. We learn about duality, dual theorem, shadow price, dual simplex. And this week we talk about the revised simplex method and also a software that is called QM for Windows. And oh yeah, I forgot that we also learned about goal programming right after the midterm exam. So that's all. Thank you and good luck for your exam, and good luck for everything that you do in the future. Okay, and then I guess see you when we see each other again next. Okay, thank you.